So the next thing we're going to do is we're going to calculate a t-test. And this will probably take maybe 30, 40 minutes. And then we'll wrap up and then we'll call it good. So the t-test is it's called a type B study. So what we did up till now was a type C study. And that's where the whole corpus is the unit of analysis. A type B study is where we have the text as the unit of analysis. So there's a big difference, because if we take the whole corpus as the unit of analysis, we just say that all the L1 English speakers use it 56 times. That's just representative of L1 English speakers. But if we use a type B study, then we can calculate averages that will also allow us to have standard deviations or standard errors, where we can better reflect the contours of the data, and we can also capture, and here's the big thing, we can capture the similarities, right? So if I say the Japanese students use the phrase frame all the blank in 162 times, and the English L1 students only use it 29 times, that's a huge difference. And it will probably be a big difference when we do the t-test as well. But what you easily forget with those numbers is that out of 400 people, they used it 162 times. But probably 300 people didn't use it at all, right? So if I say 162 versus 27 or 29, that's a big difference. But if I say, out of the Japanese authors, 300 didn't use it, and I say out of the L1 English authors, I'd say 370 didn't use it, 300 and then 370, that difference doesn't feel as big as the difference between 29 and 162. So the type C study ignores all the people who don't use it. But the type B study, not only does it capture the people who use it, it's also capturing all the overlap of the people who don't use it, something that a type C study ignores. So we can use a t-test to try to better understand, better capture the similarities. Rather than focus only on the difference, let's focus on the difference, but also focus on the similarities. So, to access a t-test in Excel, do you guys have Excel on your computer? I recommend you guys open up Excel, and then go to File, and then Options, and then you can click Add-ins, and select that from the drop-down menu, and then down on the bottom, there's going to be like a little Go button down here. It looks kind of like this. So once you get to Options, you click on this Add-ins, and then you go down here and click this little Go button.
Can you do that? Yeah,
So you click Add-ins, and click, oh, and then you got to check the box next to Analysis Toolpack and Analysis Toolpack VBA, and click OK. Yeah, so here's the Analysis Toolpack, and then, so you want to make sure that these two are added, and then you click OK. That you should be able to find up here on your Excel in the data analysis, under data and data analysis, there will be the option for a t-test. So if I go to mine, and I go to data up here, then I have this data analysis little tab over here, and now I have all these statistical packages added to Excel. Okay, so you go to data, data analysis, and then you have all the stuff you need. And that's getting the data ready to run the analysis. Getting the data ready to run the analysis is always a super important, super difficult, super boring part. Actually running a t-test, running an ANOVA, running a regression, running a multiple regression, it's all quite easy because you just push the button and it goes. But you have to have the data set up nicely for it to run well. Lawrence, have you run a t-test in Excel before? No? Okay, very good. So what we'll do is we're going to get something here called, we're going to set our data up in long form data. Okay, so there's long form and there's wide form. Usually, when you make a spreadsheet, the human brain wants to make it in wide form. We want to have a column for each variable. So we want to say like L1 Japanese row, L1 English row, the blank of the column, it is blank to column, that's wide form. We don't want to go wide form though. We want to go long form data because most statistical programs and programming languages like Python and R, Excel and things, they all prefer long form data. So we want to put our data into long form. Getting data into long form is easy, but it takes a few steps. So this is what we'll do. I will put my data into long form for the blank of that. And then Gary and Larry, I want you guys to go along doing what I do, but I want you to do it for all the blank. What you guys were all the blank in? Was that your, which was your phrase frame?
It is.
Okay, so you guys do it for it is blank for. And then the group in the back, you guys do the same thing, but for all the blank in. And then we'll have all the data we need ready to go in long form. Okay? So, how are we going to do this? Oh, it is a pain. Okay? So, in Excel, I would recommend, actually, let me show you guys what it looks like in the end. Let me just show you real quick what it looks like in the end. Here's the end, what it's going to look like. So I have here, this is the file number up on top. I have multiple sheets. I have a JP sheet for Japanese. I have an ENS sheet for English. I have a long form. This is the data that we're going to run the analysis on. And then these two sheets, these will appear after we run the analysis. Okay, so I have these first three is what I have. So we'll go file, or we'll have file number, put number here, word count, then the frame that you're looking at for a JP. And then you can do the same thing for ENS, or EN, right, for English. Like that. So what I'll do, I'll just copy this. And I'll put this one in my new one here. I'll go like this. Copy that in there. My frame is the blank, no, the blank of the, okay, that's mine. That's for the JP. And then I'll do the same thing for ENS. Okay? So if you guys can set up yours to look something like this, and then in column C, you'll just have your own phrase frame, it is blank for, or all the blank in it.
This computer will have the Excel. I need to log in.
Okay?
Oh, you want to watch mine?
And then in column A, we want to make sure that we have 400 files, data for 400 files. So this is how I would do it. I will go 1, 2, 3, like this. Probably Professor Fung has a better way to do this than I do. Then I would grab these like this, and I'll just pull it down to about 401. and it fills it in the rest like that. Right, that reflects the 400 files. Is everybody okay? Okay, now what we're going to do is we're going to start to populate these columns, okay? I'm going to work first on my Japanese one because I need to pull information out of AntConc to do this. So I'm going to go back to AntConc, and I have the blank of the, but instead of using quick, I'm going to use this tab here, plot. Okay? So I use plot, I have the blank of the down here, and I hit start. So you guys please use plot, and then put in your phrase frame, and then hit start. Now notice, keep track, you guys, it looks like you have the English one here, so you want to make sure to put that in the English one there, right? When we start moving it. Mine's on the Japanese one. You guys are also on Japanese. Okay, good. Okay, so that's good. We'll have to do it once for Japanese and once for English. Okay, so if you're doing English, copy the stuff into your English file. If you're using Japanese, copy it into the Japanese. So now what you do is you'll just take this and just select these two rows like that. I'm going to go Control Copy. Then I'm going to run it back over to over here. And I'm going to paste it in. So I'm going to go like this. I think I can just do this. Yes. Okay, change the file headings, but that's okay. Okay, so now I have the number of tokens and the frequency in file number 1, file number 2, file number 3. Okay, so I got all this stuff. Now, what we're going to do is we're going to calculate normed rate. Oh, here's a super, super, super important step. So remember, we want to reflect that. Here's all the files that have it. But check this out, only 41 files have it. Now, the rest of these 400, the remaining files all have 0. So we have to put that 0 in there. I'll put in 1 0. Hold my cursor here, make it turn into the little black cross, and I'll double click it, and it will fill in all the zeros for me. So now I have my 400 instances are covered. I'll just leave it like that. Column B we'll use to get our normed rates. And now we have this. Okay, now we're going to calculate our normed rates. And our normed rates will show up nice for everything up until 0, because you can't divide by 0. So we're going to do our normed rates, and we're going to calculate. So file 1 has 5 instances of the blank of the in the Japanese texts. And then I'm going to take 5, I'm going to divide it by 209, and I'm going to multiply it by 100, so I can see per 100 words, how many times does this phrase frame appear per 100 words. So this will give me a normed rate. And the reason we want to use a normed rate is because all of these files have slightly different numbers of words. So longer files are more likely to have repeat words. So rather than calculate the raw number, we want to calculate a normalized rate per 100 words. We're going to use 100 because these are very small files. So this is how I'll do it. Let me show you guys how I'll do it. I'll hit equals, I'll hit percent. I'm going to take the frequency there, I'm going to divide it by this one over here. I'm going to put another thing there, I'm going to multiply it by 100. Okay? And this is going to be my normed rate for that file. Now, then I just want to apply that to everybody, so I'll do that thing where the cross here turns black in the corner, double click that, and it will fill in the rest, right? Like that. And then, when I get to my zeros, it says I got this divide by problem, so that's fine. I'm just going to delete all these. Just going to delete all those and replace those with zeros down there. Okay? I'll just replace all those with zeros. Boom. Now I have my norm grades. But, well, here, I'll stop for just a moment there with you guys. Okay, has everybody got here? Now here comes another important moment. Okay, here's an important moment. What we're going to do here is I'm going to select all of these. I'm going to cruise on down. I'm going to select this whole row. And then, so I'll select it here and I hit copy. All right, so I copied it. This whole thing's in copy, right? Now I'm going to paste these in here, but I'm going to paste just the number. Because I don't want to paste the formula. I just want the raw numbers in there. So, what's that?
The value.
Okay, the value. The value equals just the raw number.
That's what they see.
Oh, okay, so paste the value in there.
你说这个数字，对，他讲数字，因为你们一直
The value in there, you can see here. So Roy, if you look up here like column E, if I click on a value in column E, it shows me a formula. But now if I click on it in value in column D, then I see just the value, right? So I don't want the formula. So what I'm gonna do now is I'm gonna just delete the formulas. The formulas are gone. I don't need them anymore. I don't want them to confuse me. Now I got the normed rates. Just gonna save it like that. Save. Okay? So now what I want you guys to do is do the same thing, but do it for the English corpus. And then you guys do the same thing for the Japanese corpus. So you gotta go back to AntCon, load it up,
not 150.
and please repeat the process for the other corpus.
And these change into real. Yes. You just type 1 in real. Here. Type 1 in real. Minus 1. Okay. And use this here. And copy the number to this.
The normed rates again. We'll just do this. Frequency divided by the tokens times 100 equals that. Around now to do. Next step, here's where we're going to move into the long form data. We're going to take all the numbers we generated, we're going to move them over to long form data so we can do the F test and the T test and calculate Cohen's d. Okay? Probably should be done in about 15 minutes. So I have a tab here for long form, and what I did was I put my group and then frequency. Okay? So my group, I'm going to have two groups. I'm going to have ENS for English, and I'm going to have JP. I'll have EN for English and JP for Japanese. Okay? Now remember, we have 400 files, so I want this EN to go from 2 all the way down to 401 to represent my 400 files. And this is where it gets to be long form data. Okay, so I'm going to go down here to about 401, I think. Okay, so now I got 400 cells filled up for ENS, right? 2 to 401. Okay, good. Now, I want to take that data, the frequency data, and I want to paste it into here. Okay, so I'm going to go back to my ENS sheet, take these normed rates, and I'm going to grab all of these 400 normed rates for English. I'm going to copy them. So I go here. Oh crap, don't do that. Never mind, don't do what I just did. What I just did was bad. Okay. I'm going to copy this whole column like this. Just copy it, just select it on top and copy it. I'm going to go over here to long form. I'm just going to paste her in there. Just going to paste it like this. Control V. Okay? And I can change the name back to frequency if I want. Okay, now if I go down, I should have zeros all the way up to that 401 mark, right? Okay? So now I have my long form data for my ENS, for my English group. So remember, this is group here. Column A is group. Column A is group. Now in the same column, I want to add my Japanese group. So I want to add JP. So I'm going to go down to where the end of English, and starting at 402, I'm going to put JP. Okay? I want that to go, and I think it'll go down from 402 to what? 801, right? For the 400 files there, I believe. So I'll take that out at 801. Now, I'm going to paste in all of the values for the JP one. So what I'll do with this, guys, this is what I'll do for the JP. I got this one here, and then I'm gonna select this guy, and then I'm gonna cruise down to the bottom, and then I'll do a control click. Oh, I'm sorry, I was supposed to do shift click, wasn't I? So I select this one, D2, and then I scroll to the bottom. Well, that one's selected, and then I hit shift click, and then it selects them all. And I copy those. I go back over to my long form, go back to the Japanese one here, and then I paste it in there. And those numbers should match up, my zeros should match up to the other one. Okay, now I got 400 JP files and 400 ENS files, EN files in long form. And this is what I want. I want my long form data. I'll just hit save there. So it's all saved nice. Okay? The next thing I want to do is I want to run my t-test. But before I run my t-test, I have to figure out, do my groups is the data have equal variances, right? Because that's an assumption of a t-test. A t-test assumption is that both groups have equal variances. So I can check the equal variance. That pops. So if you guys don't have this, I'll just delete these tabs. These tabs will appear later. They'll come out like this, okay? So I'll delete these tabs and we'll just run them new. I'll just delete that. And then what I want to do is I want to go to data. I want to go to data analysis. And I want to use an F-test for 2 sample for variances. I'm going to compare the variance of the data, right? So I go to data, into data analysis, and I'm going to choose this F-test, 2 sample for variance. Maybe it says something different in Mandarin or whatever it looks like. Maybe you guys can find it. Okay, so I'm going to select that, select the F-test, 2 sample for variance, click OK, and it's going to ask me to put in the variable range for the first one. So for English, I'm going to be grabbing B2 to B401. I'm going to cruise down here. Okay, so I got my first one in there. Next, I'm going to click down here and do my variable for my range for variable 2. And that's going to be 402. I'll do that shift move again so I don't have to drag the whole time. I'll go down the bottom here. And I will shift like that. And I've done it. And then it says new worksheet. When I run this, I'm going to make a new worksheet. So I'm going to call my new sheet, I'm going to call it equal variances test. I'm just going to name it that so I remember what it is. Because a new worksheet will appear with the calculation. So I got my range 2 to 401, 402 to 801 looks good. It's all good. Okay. And then I click OK. And this is what I get. Comes out with my new sheet. Make it a little bit bigger. Looks kind of weird at the moment. And I remember variable 1, I'll change that name to ENS for English. And I'll change variable 2 to JPN for Japanese. I remember I did it in that order. Okay. Oh. And now, here is the important point. This is telling me that it's 0.03, my p-value is 0.03, which means the variances of the two groups, Japanese and English, the variances are statistically different. They are different to the point of statistical significance, which means they do not have equal variances, which means when I run my t-test, I need to use a t-test that assumes unequal variances because the variances between these two groups is unequal. Okay? Normally, when you see this p is less than 0.05, you think, yay, I got a significant difference. And you do have a significant difference, but your significant difference is that the variances between these groups are way different from each other. And a regular t-test assumes that they're not way different from each other. So because they are way different from each other, we can't use a normal t-test. We need to use a Welch's t-test, which assumes that the variances are unequal. And these variances are statistically significantly different, meaning that they are unequal. Okay? So that's cool. So now, I'm going to run my t-test. So I'll do the same thing I did before. I'm going to go to data analysis, but this time, I'm going to cruise down here to the bottom, and I'm going to pick a t-test to sample assuming unequal variances. Okay? I just ran the f-test, and I know that the variances are unequal, so I'm going to assume unequal variances. Then I click OK. And then it's going to ask my variable range. So I'll go back up to the top and put my English variable range in there. Pick you guys first. I'll scroll to the bottom, and then I'll hit Shift-click right here to get all of them. So that's variable range number 1. Variable range number 2 is going to be my Japanese. So I'll click that one. Scroll to the bottom. So I get to about 801, and then I will shift, click, variable range number 2. My new worksheet, I'll call t-test. I'll just call this one t-test 2, because I already got it. And then I click OK. And I've done my t-test. Takes a minute for Excel to settle down after running that statistical analysis. Okay, variable number 1 was the L1 speakers of English, so I'll call them ENS. Variable number 2 was the Japanese, so I'll call them JPN. And my p-value is 0.35. So they are not, there is not a big difference with the frame and my group. Yep. And we could have guessed that with the 66 versus 57. Okay? So then, how about you guys? What did you get? What was your p-value on your t-test? Whoa, your p-value is super significant. Yeah, that's very good. How about you guys? Also super significant. Very good. Very good, very good, very good, very good. Good. Okay. So far, we can see that we have two different statistically significant differences with it is blank for and all the blank in. Not the case with mine. Okay? So what we're going to do next then is we're going to calculate the magnitude of that difference. Okay? So the magnitude of the difference is going to look like this. With that t-test, so this is what we had here. This is what we just produced this, right? We produced that something that looks like this. I don't have a statistically significant difference. We're going to take this and we're going to calculate what's called an effect size, Cohen's d. Okay? So the way to calculate Cohen's d is you take the difference in your means and then you take your pooled standard deviation by doing this formula here, and then you divide that by that, and then you get your effect size. And your effect size shows the strength of the difference. So if you have an effect size like 0.6, that's really good. 0.8 is super good. If you have an effect size of 0.01, then you're like, okay, my p-value was good, but actually the practical significance, the practical difference is marginal. It almost doesn't matter, even though my p-value is statistically significant. So to do this, we want to calculate our Cohen's d. Okay, so maybe around column E in here. Why don't you guys type in this like Cohen's d calculation. We'll do that around column E. And then we'll do our difference in means. So for your difference in means, please subtract the bigger mean from the smaller mean. I'm going to subtract this one. I'll do JPN first because JPN is my bigger mean, right? If you have whichever mean is your bigger one, just subtract that one from the smaller one. Okay, so that's my difference in means. Okay, then I'm going to do my pooled standard deviation. So here will be the pooled SD, standard deviation here is what I'm going to do next. And we calculate that by doing the square root of the variances, the sum of the variances divided by 2. And our variances are right here. So if we go look at our variances, here's the variance in, for me it's in row 5. So if I look at that, again it's the square root of the sum of the variances divided by 2. So I'll put equals SQRT equals square root, like that. I'll add one more parenthesis. I'll take that plus that parenthesis divided by 2 parenthesis. That's my pooled SD. Looks like that. Plus the square root of B5 plus C5 divided by 2. And then my Cohen's D, this is the effect size. My Cohen's D is going to be equals the difference in the means divided by pooled SD, enter. So my effect size is 0.06. Super, super, super small. Very small amount for the effect size, okay? So your effect size will be G5 divided by G6.
G5.
G5 divided by G6. 0.8, very big. Very powerful effect there. 0.56, very good. Very good effect. So now you have, now not only do you have, is this statistically significantly different? Yes, it is. With your Cohen's D of 0.56. So that's a strong difference. You guys have a very strong difference, and you guys have a strong difference. Mine has no big difference at all. Okay? So with this current set, we looked at 2 different ways to calculate differences. We had the per corpus approach and the per text approach. We had log likelihood, and then we had the t-test. Here, we got the same answer. We got the same outcomes. We had both ways led to statistically significant differences, if we did log likelihood or if we did the t-test. However, I would argue that with the t-test, we're able to get more information. We got mean scores, we got standard deviations, we're able to calculate effect sizes, so we can paint a more complete picture of the data. And I have found on numerous occasions where log likelihood will lead us to a statistically significant difference, but on that exact same data set, a t-test or a per text approach will lead to not statistically significant differences. So you can have the same data set, but get different results based on your method of analysis. So I see personally, if you have the chance, if you can do a per text approach, I see no reason not to do it. You only get, at the very minimum, you get more data, you get an effect size, you get standard deviations that you can report, and that's great. And then possibly you will save yourself from committing what's called a type A error, a false positive, where you say these are statistically different. Yeah, if you do log likelihood, if you do a per corpus approach, they are, but they aren't if you do a per text approach. Okay? Do you guys have any questions? Questions or comments?